Hello everyone. Here we're going to be talking about evaluating outcomes. And the way in which we're going to be doing that is we're going to be talking about an idea called Pareto efficiency. So here's the idea. Look at this thing above me. Here we have people caught in a traffic jam. Now, the idea that we want to think about here is that people basically would prefer to avoid being in the traffic jam. So that's the basic intuition of the idea that we have here for talking about how to evaluate different outcomes. So, a concept that is widely used to evaluate economic outcomes is termed Pareto efficiency. So what's the idea there? The idea is simple. An objective for public policy and for institutional design, for the rules of the game that people are going to play by, is that people should try to avoid outcomes that are worse for everyone compared to an alternative feasible outcome. Okay, so here we want to think about something like the traffic jam. An alternative feasible outcome could have been an outcome in which maybe the traffic was moving more smoothly when people were able to drive more quickly. What would the institutional design be that would be able to promote that kind of outcome rather than the outcome of the traffic jam? So other outcomes that people would prefer to avoid, and we've said here a traffic jam, but the other one is, as we saw earlier in the chapter, the fact that people plant late in Palanpur. When people plant late in Palanpur, both parties are worse off, both farmers are worse off. As we see in the fisherman's dilemma game, we see that people overfish. When people overfish the lake, they both end up in a mutually disagreeable outcome. So that's the basic intuition here. But then we want to think about this in a more formal way. So the first idea that we have to define is one of what we call Pareto superiority. Now the person here, the term Pareto, this is named for a guy called Vilfredo Pareto, so we're just using his name. The same way that we use the name of John Nash for Nash equilibrium, we're using the name of Vilfredo Pareto for the understanding of Pareto efficiency. So what's Pareto superiority? When we're comparing two different outcomes, so one outcome A and another outcome B. So think about those two outcomes. We say that outcome A is Pareto superior to outcome B if in outcome A at least one of those involved is better off than in outcome B without anyone being worse off. So imagine at outcome A we had two different players. At outcome A with these two different players, one person got a payoff of 3 and someone else got a payoff of 2. At outcome B, one person got a payoff of 2 and the other person got a payoff of 2. Here I have a Pareto superior outcome, outcome A, versus outcome B, because at least one person 1 over here, is better off than an outcome B, and the second person who gets a payoff of 2 in both circumstances, they're as well off as they would have been. Okay, so outcome A is Pareto superior to outcome B. Had it been the case that we had payoffs of 3 and 3 here versus 2 and 2, it's also the case that outcome A is Pareto superior to outcome B. Okay, outcome A is Pareto superior to outcome B in the second case because both players are better off. Okay, so they're both doing better, therefore it has to also be Pareto superior. So that's Pareto superiority. Now, Pareto efficiency is basically thinking about an outcome and saying for that outcome, an outcome is Pareto efficient if no other feasible outcome is Pareto superior to it. Okay, so here we have to think about this in negative terms. If there's no alternative outcome that is Pareto superior to a given outcome, then that outcome is Pareto efficient. This is going to become clearer when we think about an example. So let's return to the prisoner's dilemma game and think about what that will look like in terms of understanding Pareto efficiency. So here we have the prisoner's dilemma game. We have the two players, Alfredo and Bob, and we have the 4 different outcomes. The outcomes are 3-3, 2-2, 4-1, and 1-4. The payoffs they receive at the different kind of overlaps of the strategies they could play. So when both play 10 hours, they get payoffs of 3. When one plays 12 hours and the other plays 10 hours, they get payoffs of 4 and 1. When one plays 10 and the other plays 12, they get payoffs of 1 and 4. When both play 12, they get payoffs of 2 and 2. Now notice here, what have we done? We've labeled each of those outcomes A, B, C, and D. What we're now going to want to think about with those different outcomes is how we can compare them to each other. So here's a few questions you might want to ask yourself, which we're going to try and endeavor to answer now. The first question is, what outcomes do the players want to avoid in this game? Where would they rather not be? Secondly, is any one outcome Pareto superior to another outcome? Can we compare these outcomes in this game and say, this outcome is Pareto superior to that outcome, like outcome A and outcome B in our previous example? And finally, are any of the outcomes Pareto efficient? When we think about that, is any alternative outcome Pareto superior to the outcomes that we're considering? So those are the three questions we have to ask. Now, to do this and to make our lives a little easier, what we're going to do is we're going to take the payoffs for the players and the gain table that we have, and we're going to put this into axes corresponding to the payoffs that each player can receive. So let's look at this. Above me, I have the labeled payoffs that each player gets. Okay, so I've got 2-2 labeled A. I've got 1-4 payoff of 1 for player A and payoff of 4 for player B, and that's labeled payoff outcome D. When both get payoffs of 3, that's labeled outcome C. When player A gets a payoff of 4 and player B gets a payoff of 1, that's labeled outcome B. Okay, so let's do the following. Let's put those on our axes. So notice here, what am I going to do? I've got Alfredo's payoffs on the x-axis. I've got Bob's payoffs on the y-axis. Now, if I'm thinking of the payoff 2-2, so where each player gets a payoff of 2, I get Bob getting a payoff of 2 and Alfredo getting a payoff of 2. Let's make some dots here, and we can take that outcome, put a dot there, and we can label that outcome A. Outcome A is where both players get a payoff of 2. Now, what does that correspond to? That corresponds to the strategies where players both played 12 hours. Alfredo playing 12 hours, Bob playing 12 hours, they both got payoffs of 2 at that outcome. Now, let's fill in the other ones. We've got when Alfredo plays 12 hours and Bob plays 10 hours. What we know there is Alfredo gets a payoff of 1 and Bob gets a payoff of Alfredo gets a payoff of 4 and Bob gets a payoff of 1. That is labeled outcome B. Then the opposite is when Alfredo plays 10 hours and Bob plays 12 hours. What we see there is Alfredo gets a payoff of 1 and Bob gets a payoff of 4. That is outcome D. And then we can think about the final alternative outcome, outcome C, where both players get a payoff of 3. That occurs when they both play 10 hours. So that occurs over here. And that is outcome C. Now, the reason we've done that this way is that this allows us to understand whether there is an alternative outcome which is Pareto superior to another. So let's think about this and use some highlighters to understand what we're going to do. So to think about that, here's what we're going to do. We're going to start off with the outcome A. What we can think about with outcome A is whether there are any alternative outcomes that are Pareto superior to it. So when we think about that, I'm just going to draw a highlighted set of lines. And what we want to think about is if any player gets a payoff greater than 2, then that player is better off. If the other player is kept at a payoff of 2, then they'd be as well off. Now, what can we see here? If I highlight everything to the northeast of payoff A, what I can see is any outcome that is Pareto superior to outcome A. What do we notice? When we compare the outcome 2-2 with labeled A with the outcome 3-3 labeled C, what do we see? Outcome C is Pareto superior to outcome A. Both players are better off. They both get payoffs of 3 versus where they both got payoffs of 2. So this means that outcome C is Pareto superior to outcome A. Both players would prefer to be at outcome C rather than outcome A. So comparing A and C, if we're looking at both of those, both players would prefer to be at the outcome where they get 3 and 3 versus 2 and 2. So what do we say there? outcome C is Pareto superior to outcome A. Right? So C is Pareto superior to A. Now, when we think about B and D, we're in a bit of a bind. Here we can think about this and say, is D or B Pareto superior to any other outcome? The answer is that they are not. All right, so they're not Pareto superior to either A or C. If we had to move from either outcome A or outcome C to outcome B or D, what has to happen? Another player has to be made worse off. So if we're moving from A to B, what has to happen? Moving from A to B, if we thought about that, and we're asking ourselves that question, player A would get a payoff of 4. That would increase player A's payoff from 2 to 4. That's an increase of 2. But what happens for player B? Player B their payoff is decreased from 2 to 1. They're worse off. Therefore, outcome B is not Pareto superior to outcome A. We have the same kind of question when we're thinking about moving from A to D. What do we see there? We're going from 2-2 to 1-4. So what does that mean? Player A's payoff, Alfredo's payoff, must go down in order for us to move from player outcome A to outcome D. Therefore, it's not Pareto superior, right? So outcome D is not Pareto superior to outcome A. All right, so the only comparison of Pareto superior outcomes is outcome C is Pareto superior to outcome A. That's the first thing we have to know. So in terms of these 4 outcomes, we say outcome C is Pareto superior to outcome A. We haven't yet diagnosed whether any outcome is Pareto efficient. To do that, what do we have to see? We have to see, is there any alternative outcome which is Pareto superior to our outcomes? So we have to think for outcome B, C, and D, are there any alternative Pareto superior outcomes? We've already said that none of them is Pareto superior to the other. But is there an alternative outcome that is Pareto superior to them? To do that, we have to know whether there are alternatives to the northeast of those outcomes. So the first thing that we can see is looking at outcome C. Outcome C has no alternative outcome which is Pareto superior to it, where at least one person is better off and no one made worse off. Outcome C is Pareto efficient. If we look at D and B, similar things happen. Looking at outcome B, is there any alternative to the northeast which is better for other people? For at least one of the person without making anyone else worse off? No, all right? There is no alternative outcome which is Pareto superior to outcome B. And then finally, with outcome D, again looking to the northeast of that outcome, what do we see? Is there any point in that area? No, there is not. If there is no point to the northeast of a given point, that means there is no alternative Pareto superior point. So the funny thing here is we're left with 3 Pareto efficient outcomes. We've got 3 Pareto efficient outcomes. We've got outcome C, where they get 3-3. We've got outcome B, where 4 and 1. And we've got outcome D, with payoffs 1 and 4. All 3 of those outcomes is Pareto efficient. So in this game, the Fisherman's Dilemma game, the Nash equilibrium of the game, where both players fish for 12 hours, is Pareto inefficient. There's an alternative outcome which is Pareto efficient. So the Nash equilibrium is Pareto inefficient. All 3 other outcomes are Pareto efficient. That's one of the weirdnesses of the Prisoner's Dilemma game, or here the Fisherman's Dilemma game. So that leads us to the same figure that I have here, but just more formally drawn, where we have comparisons of the different areas to the northeast where there are no alternative outcomes that are Pareto superior to outcomes D, C, and B, as corresponding to the table that we have. When we see that, we think, okay, there are 3 Pareto efficient outcomes. Now, when you see this, you might immediately think, all right, but how is this helping us? What Pareto efficiency says is that people should avoid outcomes where someone could be made better off and no one else would be made worse off. We should avoid those outcomes. We should try to achieve those outcomes where there is an alternative that is Pareto superior. Now, Pareto superior tells us nothing about fairness. It tells us nothing about equality or inequality. So the important thing here is that when there are many Pareto efficient outcomes, like we just saw, there are three of them, 1, 4, 3, 3, 4, 1, those were the payoffs at the game. What we see is that among those outcomes, people have a conflict of interest. Alfredo would like to get a payoff of 4, Bob getting a payoff of 1. What would Bob want? Bob wants to get a payoff of 4 when Alfredo gets a payoff of 1. And finally, there's this other one where they both get 3. That's somewhat okay. And they're both doing better than the alternative where they could have gotten 2 and 2. But among those three outcomes, they've got conflicts of interest. They don't all agree about which one they would like to end up at. And so we can have many Pareto efficient outcomes in a game, but Pareto efficiency doesn't tell us which of the Pareto efficient outcomes players would actually choose.